let's get it on with the next one. So let me just share this one with ya. What the hell did I just copy? I copied some weird link. There we go. Yeah, see if you can access that Excalidraw link.
All right, and there we go.
Okay, looks like you're in. Sweet. All right, so yeah, system design number 2 for today. Thanks for joining us, energetic sheep. Do you want to give a quick introduction at all, or do you want to remain anonymous?
I think I'll remain
Okay.
anonymous. Keeps more anticipation.
Anticipation. What are we anticipating today?
The epic design of something
Okay.
great.
Okay. Right. Oh yeah. Right. We were talking yesterday really quickly about what we're gonna do. Okay. Do you want the medium difficulty one, or do you want medium as an appropriate for what you put together, or do you want something that's a bit more challenging, a bit more stretchy?
Uh, I think you know what? Let's go
Let's go
challenging.
challenging.
I'm feeling
Okay.
lucky.
Uh, Today we're gonna design a monitoring system. Okay. This is gonna be in the context of a cloud monitoring system. Okay, so you can imagine the system. Let's call it, I don't know what the Google one's called because I want to keep things like Google themed, but it's kind of funny. But let's call it, Cloud Watcher or something. Okay, and the premise is that
Okay.
you ingest information such as logs and metrics that are emitted from other applications, and following rules, you can aggregate and compute aggregate statistics to then broadcast out.
Okay. So stuff like average response time,
Yeah,
average time to first byte,
yeah,
that
that
sort
kind
of
of
thing.
stuff. Yeah, that's right.
All right. Is there any other high level info?
No, we'll just start with this kind of functional requirement. This should be there should be a pretty good base to kind of at least get our feet wet.
All right. Sounds good. So, what sorts of features do you want me to focus on?
Features? No, these are the features right here. So you have a ingest endpoint for logs and metrics, and this is per application, or
Okay.
per some key which is customer specifies, and then from those the customer also specifies rules. So like you can say, for example, a rule is average. For example, okay. So
Okay.
in that pipeline of logs, you want to average them out, and then broadcast that continuously.
Okay. So, if I understand correctly, you essentially this monitoring system effectively collects info in real time and then computes these
Yes,
computes information from these so-called rules.
yes, also in real time.
Okay. All right. So, a couple of things, if I understand correctly, we'll be reading from multiple services. So, like, if we have like service
Mm-hmm.
1 and then service 2, and then say this, so I'll call this S1, I'll call this S2, monitoring, then we can have both of these sending data at the same time.
Yeah, they can be sending. Yeah, they can be sending data at the same time, and also keep in mind that you know, in this context, it's not necessarily that these are two logically separate applications. So, for example, if these two applications are both given the same aggregation key, their statistics would be considered in aggregate, as if they were one application.
Oh yeah, because in the case of like you may have different server
Correct.
replicas that are sending
Correct.
data. Okay. Okay, so we but there may be services that have different aggregation keys and we may want to collect data differently for
Yep, that's
those.
right. And then yeah,
All
so
right.
in that case, right? So you can imagine that it would be outgoing. The outgoing data would be per aggregation key. Yes.
Okay. So, well, since ingest info such as logs and metrics is very, very
Mm-hmm.
flexible to store information, I don't think we want something very schema based, or if we want schema based, we want the user to be able to customize it. So I don't think something like relational would be ideal here because if the user changes their metrics, then it could get annoying to change it in relational. So
Mm-hmm. Okay.
I think for starting out, we have. Do we want to use? Because I'm thinking of using databases to store info, but then how do we make it where you were not kidding when you said this one was challenging? Oh my god.
This is a stretch one, so you don't have to worry too much about like let's just get the like a solution down first, and then we can talk about how scalable and realistic it is. So don't worry about the non-functional requirements as much first. We can iterate on that as we go. One thing about the data that we want
Okay.
to talk about is keep in mind that this is time series data, right? So this is distinct from, like,
Okay.
for example, business logic data like users or files, right? We're talking about time series
Yeah.
data. So all data coming in will have associated timestamp, and a timestamp is going to be highly relevant in terms of the data that we want to work with.
Okay. So timestamps are relevant. Is there a circumstance where we would want to uh, keep info for very extended periods of time? Because you
Mm-hmm.
mentioned computing
Yeah.
aggregates, but that implies like we use the info to compute aggregates and we potentially discard it. Is that the
Yeah, so
case or
real
no?
time in this context just means that we want to say, first of all, real time, but real time, you can say, let's assume that we're allowed something like a 1 minute delay. Let's say that's acceptable, okay? So real time, 1 minute delay. And also, real time in this context for logs and metrics means that we are, we're computing these rules on a relatively small fixed period of data. So, for example, last 10 minutes per aggregation key. And so data,
So reasonable.
yeah, so like reasonable
I'm
timelines,
sorry.
like a latency of 1 minute and a live running count in the last 10 minutes, I'd say is reasonable. And data that's older than 10 minutes, we don't need to consider for computation, but we don't want to toss away, right? We still want to persist that somewhere else. It just won't be part of our monitoring system. That's right. So, in other words, we don't care
Okay.
about data outside of our context window.
Okay. And for data in the general sense, you said we still want to keep it. Do we have a time limit for how much we want to keep that, or is it stored for
No, so
eternity?
just to be clear, we won't be designing the system which keeps it. Keep in mind that we're just a monitoring system, and so there you can assume that the system which broadcasts logs to us is also responsible for broadcasting logs to someone else to store. So we don't need to store logs longer than our let's say 10 minutes ago.
Okay. So then let's say we have like a set of services, service 1 to service
Okay.
n, and they send data to our monitoring server.
Mm-hmm.
So to since you mentioned something like real time, we may want to have like a message processor in the middle that can ingest real time data. So like some sort of streaming service. It could be like whatever, like Kafka or your favorite real time data processing service.
Okay.
It's ingested into there. And then Kafka ingests it into our monitoring service. What our monitoring service then does is adds the data, and then every so often, with the 1 minute delay you mentioned, I think, is sends the aggregate data to whatever external thing that we choose. In this case, are we allowing the user to specify an external storage with which we send the
Yeah,
aggregate
so you can
data?
assume that the end user, it gives us the endpoint per aggregation key. And what are you drawing? Whoa,
I do not know
you used the
what.
wrong arrow.
Yeah, I tried to draw one arrow and
I
it's
think
like
he uses
not
squiggly arrow.
cooperating.
Anyways, yeah. So two things to clear up here. So the first thing is that we don't. So we don't need to like display it. Like we just need to send the data off, right? So the user will specify, and so they'll specify which services are encapsulated under what aggregation keys, and so you have up to, let's say, in aggregation in services that input it to one key, and one key will have one output. Well, and there'll be an endpoint that you're supposed to call. Okay. And the second thing, which I think you got twisted up there, which is that real time in this context means that you can be up to 1 minute delayed in sending data, and that would be considered real time, be considered okay. but it doesn't mean that you send once per minute. You still send as often as you can.
Yeah, you still like send it as fast as you possibly can. It's just 1 minute is like a
That's correct.
tolerance
Yes.
we have. So the reason I specifically mentioned something like Kafka is I forget the name of this, but it has features for like maintaining different lines of communication for real-time data.
Okay.
So if we have like a set of aggregation keys, we could have like one line for each aggregation key so that separate aggregation keys can't like interfere with other aggregation keys processing.
Okay. Can you describe a little more about how the lines would work if so Kafka is in memory. The I
Yeah.
guess the the merge compute part. How familiar are you exactly with message queues and Kafka and the like?
I know at a
Okay.
high level what they do. I'm not aware of the
Okay.
intricacies.
Do you know about the merge compute cycle?
I
Okay.
do not.
So let's back it up then. That's fine. So yeah, I would agree that Kafka would work in this context, but Kafka would not work if there's too much data per merge key.
Oh, so like if one aggregation key just sends a ton of data and then since it's in memory, there's very limited capacity to
Well,
transfer it.
yeah. So
Okay.
there's a throughput limit on that in Kafka, right? So I agree that it would be logically correct, right? But that might not fit the functional requirement of latency. And the second part is that, and I think you know this part. I'm just letting you know ahead of time, right? Is that one Kafka instance won't be enough. So, right?
Yeah,
Okay,
yeah.
yeah.
Like
Just making
this
sure.
is
Just
more
making
so
sure. Yeah.
like we'll have to have multiple for like also because Kafka's kind of a single point of failure. Like if Kafka goes down, then our entire thing just gets destroyed.
Yes. So yeah. So those are some concerns. So why don't you go ahead and think through those?
Okay, so would you like me to start with describing the lines
No,
or
I know the lines are pretty clear, but I do want you to describe how you will handle the situation where there are too many inputs for one line to handle within the latency requirement.
okay, if there's too many inputs for one line to handle, well, there's nothing that what you've described in the functional requirements that technically stops us from having multiple Kafka
Yeah, you can have
instances.
multiple Kafka instances.
Like if we, for example, copy this Kafka instance and have it where, and this actually creates a very good opportunity for load balancing here. Because if I am not good at scala draw.
You should get good. This is the one that people use the most.
All right, so we have some load balancer here. And the load balancer effectively decides, okay, which Kafka instance do we send to? It does this based on, okay, what's the current load on each Kafka instance? If it's full, obviously we don't want to send it to that instance. Then, yeah, we have this.
Okay.
So now we have multiple Kafka instances. I'd like to also briefly discuss what happens if, like, despite our best efforts, one Kafka instance fails for
Okay.
some reason.
Let's just stay on the happy path first. So if nothing fails, how is
Okay,
this supposed to work?
so nothing fails. Okay, so how it works is we have services that send data, and in that data is their aggregation key.
Okay.
The load balancer would take this and say, using the aggregation key as and the data of the Kafka instances, it would say, okay, let's route it to say this instance or this instance, depending on the load and what aggregation key it is.
So what if everything is one aggregation key? Or not everything, but like a lot of things, like more things are one key than one instance can support. Then what do you send it to?
Uh,
Does that matter?
More than one instance can support. Okay, then
Like we could say just for some simple numbers, right? Like let's just say for instance that Kafka can support 10 unique streams. I know it can do more. Let's just say 10. Okay. So
yeah,
what if we have 11? Then what do you do?
if we have
Mm-hmm.
11, then we may want to uh, make it where different Kafka streams can, where we don't have necessarily the same streams on each instance.
Yeah, so in other words, you must have at least two Kafka instances with the same aggregation key that have streams with the same aggregation key, right?
Yeah.
And so yeah, okay, and then continue your logic.
So my logic then would be, okay, we can introduce a little bit of sharding here, so I can like shrink this down. So we'd have two dimensions here. One would be like, okay, we have a set of streams for some aggregation keys, and we'd have multiple replicas of that for load. And then the other dimension to that would be, okay, if we have one Kafka stream that handles streams 1 to 10, and then we'd have like a separate set of Kafka instances that can handle streams 11 to 20, etc., etc.
Okay, sure. So you would still have
So,
two Kafka streams with, let's just say, all of Kafka instance one is stream one, and then the first stream of Kafka two is also stream one, key one, right? That would be possible if you had 11 stream ones coming in.
can you say that
Yeah,
again?
sure. So let's assume that each Kafka instance can support 10 unique keys.
Yeah.
Or 10 streams. And let's say in one key, let's say call it key one, we have 11 streams worth of data.
Oh, okay. So you're talking about like, there's not necessarily a one-to-one mapping between aggregation key and streams anymore.
Well, that depends on how you want to organize it, but I'm just saying that in key one, there's so much data that one instance cannot handle it, even if the entire Kafka instance is handling that same key, right? And so in this case,
Okay.
Your Kafka here, right? Your first Kafka on top left would all be doing key one, and then part of your second Kafka instance here would also be doing key one. So you have, in other words, you have two Kafkas that are in part at least handling key one. So how do you combine the data from the two?
Well, they, so, well, the thing that came to mind immediately is we just send it to the monitoring service and let it do its thing, because it's the thing that ultimately computes the aggregate statistics.
Okay.
So, because the problem with requiring like two Kafka instances to coordinate is that it gets a little bit messy
Yes.
from a consensus standpoint.
Yeah.
So what I would ideally want to have is that Kafka instances can operate independently of one another.
Okay.
And like the actual arrangement of like say aggregate key one going to multiple Kafka instances doesn't require them to like synchronize with one another.
Okay.
So I think we have to attach the aggregation key in the stream processing, and then once it gets the monitoring service, that's where it's handled.
Okay. I'm happy with that for now. So we can leave the Kafka part. Okay, what's next?
Okay, so let's go over this. So we have monitoring, which sends to an external DB. We don't really have a reason to have one monitoring thing, so we can technically have multiple monitoring servers.
And what does the monitoring thing do? So it receives a stream or multiple streams from Kafka for key one, let's say.
Yeah. Okay, and what it does with that is it would first, well, it would write to the, we'd have to have some sort of storage for like the past 10 minutes of data.
Yes.
Within either the monitoring, I don't think we can keep it in the monitoring servers, because if we want to have server replication, it would get messy, and we'd ideally want this to be stateless. And if it's stored within the monitoring server, it's not stateless anymore.
Can you talk about why
so
having it being stateless is preferable?
So having it be stateless is preferable because, let's say, for example, we have key one. It goes through Kafka, then it arrives at the monitoring service. If it is a stateful service, then we'd have to route it to the same monitoring server every single time. which is not ideal because what if that monitoring server we're sending to becomes overloaded? Then one aggregation key may be slowed down when it ideally shouldn't be slowed down.
Uh,
So
can you be a bit more? I wanna get clear on this. Can you be a bit clear on what it means to slow down, and why is that an issue? Like why like the concern is you send too much data to one monitoring server and it can't keep up.
yeah, so
Is there no way to know that that's happening? Can you like stop sending it to that server?
yeah, you can stop sending it to that server, but then the problem becomes okay, if we say some key one is sending it to this monitoring
Okay.
server, and then for some reason this server becomes too overloaded and it needs to be sent to another one. The problem then becomes none of the data from this server gets transferred to this unless we explicitly do it. And explicitly transferring the data is going to be wasteful, especially if we frequently run into a case where one server becomes overloaded and we have to
Okay, I
switch.
think can you okay, I think I see the discrepancy here. Can you explicitly describe what a server means in this context?
Okay, yeah. So a monitoring server is just some compute
Okay.
instance that computes like that sends stuff to the external DB and actually computes the aggregate
Okay.
statistics.
And when you said sending data previously, you meant sending it in memory?
Uh, as a start, yes,
Okay.
but I'm looking at this and I don't think sending it to in memory is ideal
Okay,
here.
yeah. As a hint, yeah, don't send to memory. So we want some level of persistence here, for sure. But okay. Now one more question, just for correctness purposes, is um, where are you, where are you determining which inputs at the top go to what aggregation keys?
Uh, so can you clarify a little bit what you mean? Because I was under the
Right.
impression that like for example, in some UI to our service,
Okay.
we could say, okay, here's one group for aggregation and here's another.
Yes. Okay.
Is
Yeah.
that
That's okay. And so you have a database somewhere off the side which has knowledge as to one aggregation key and a list of servers, or let's say hosts that it
yeah?
goes to the
So
server. Yeah, that we can assume that.
we have like some table for aggregations,
Yes.
and then it's like, okay, we have an ID, we have a list of services that like use this aggregation key to send
Yeah. Sure.
data,
Yeah. So
and like there's other metadata, but these are the two most
yeah, yeah,
important
cool. So
ones.
we can have this, right? So you have this table. Um, yeah. So where do you read it?
Uh, we would read it in the monitoring service when we, or the monitoring server,
Okay.
when we decide to say, okay, which I should probably get a bit more clarity on like what the monitoring service actually receives when like it gets to Kafka. So when Kafka sends it to the monitoring service, it has the uh, service ID, I think.
Okay.
Yeah,
Yeah.
the service
Yeah.
ID.
We can assume that.
And whatever data we want to send. So what we do with this is this would read from our table and say, okay, which of the aggregations does our service want to go to? And we get this a list of aggregations back, and then the monitoring service now knows, okay, we have this list of aggregations we want to send to. Then we add it to whatever uh, like persistent store we have for that aggregation data, and then send the aggregations to the external DB.
Okay. So you're reading
Okay,
it in the monitoring service servers.
yes. Did any part of my explanation not make sense?
A concern here is so you can have how do you guard against, for example, a having incorrect data. So for example, if you were to have half of key one go to monitoring server one, and the other half of key one going to monitoring servers two, they would independently compute their averages, but they would both be wrong. They would both be very likely wrong.
Yeah, because in this case they not have access to the same data because it's in memory, which is the problem.
Right. So how do we?
I somewhat
Right. So in other words, we need to have all of the data in a aggregation key on the same compute at some point, right? That's a
yeah.
requirement. Yes.
Okay, so what I'm then thinking of is like first, I if it's time series data and it's highly variable with schemas, I don't think relational is ideal
Yes.
with storing
Yeah.
it. So we need something NoSQL. Uh, I'll go over it briefly, not graph, obviously, not column since we're not doing analytics. I think a document
Okay.
store, maybe.
What are you
Yeah.
storing in here?
The document store would store. Yeah, let's decide on the. I guess schema in quotation marks
Sure.
for it because like document doesn't really have a schema. So let's have like document data and it have like ID, whatever metadata, and then you'd have a list of the objects that we're storing in this time series database. I'm not familiar with like if there's probably specific databases designed for time series data.
Right.
I'm not aware of the specific names for them, but it's probably better to use a database that's designed for time series data because they probably have built-in functionality for say cutting off beyond a certain point in time.
They do, but that doesn't really matter, and that would cheat the problem a bit too much. But do you have intuition for? So one thing you said you didn't like SQL for this problem, and you preferring document DBs. Do you have intuition for why that is?
The reason we can prefer document DBs is they allow us to be relatively flexible with our schema. Like, let's say the aggregation data that some key sends changes at some point.
Okay.
Then, if we were to enforce a hard schema, then it would get very annoying because we'd have to change it in all these places, blah, 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 and it could lead to many different problems. The benefit of a document store in particular is that they allow us to specify, okay, filter like this part of the schema. So like we could filter like ID is supposed to have this structure, metadata is supposed to have this structure, but for the actual main data stored, like make it where they can put whatever they want.
Okay. Okay.
So
I can. Okay.
that's my intuition for like why we'd use a document store if we're like not allowed to cheat and use a dedicated time series DB.
Yeah. Okay. That was just a quick follow-on question. Okay. Let's assume we want to document DB. Sorry.
All right. So we have this database, and for now, let's assume we have one. Like this isn't scalable, obviously, but like the set of monitoring servers, whenever they want to send the time series data, they'd send it to there, and they'd also query for what data's current. They have to query for what data's currently in there, and then compute an aggregate, and then send it to the external DB.
Okay.
So yeah, does this design make sense?
And just so you're explicit on this, how does this again prevent two servers from computing the same key?
How does it prevent two servers from doing the same key and having inconsistent data?
Yes. Or if you're
So
storing the
in this
data,
case,
well, if you're storing the data, I guess it wouldn't be inconsistent anymore. But you're still not addressing how the data is going to all the data for one key is going to one service, or if that's still needed. I don't know. You tell me.
it's not needed
Okay.
anymore.
And why is that?
So the data flow here is, say we have like key one and some data from key 1 is sent to server 2. Some of it is sent to server 1, and some is sent to server 2.
Okay.
English.
Sure.
And what would happen here is server 1 would upload the data it has to the entry in the document store corresponding to key 1. And then afterwards, at some point, server 2 would send its data for key 1 to the entry in the document store for key 1.
Okay.
And then whenever they wanted to send data for aggregates every so often, they'd query the document store, get the list, and compute whatever aggregates they wanted, and then send to the external DB. Does that clarify the problem you were?
So I think there's two things going on here, right? There's one thing which is updating the database with more data points, like specific data points for a query key, for an aggregation key.
Yeah.
And you have another thing which you haven't said what is. We have another thing which, quote unquote, on command, which you also have to specify, goes to the table for a aggregation key, and then performs the calculation and then broadcasts that. Right?
Yeah.
So what is doing the second part there?
So what's doing the aggregation?
Yes.
What's doing the aggregation is, assuming we know what things we want to aggregate, the server itself would be doing the aggregation.
Okay, I see. So multiple servers inside this monitoring service ingest data, which it's writing to the document database, and each of them can independently decide if they should broadcast the aggregation to the external DB.
Yeah, though, wait, I'm seeing what the problem is. Because if server 1 uploads the data and then decides to send an aggregate, and server 2 does the same thing, we'd have a lot of duplication.
Yes.
Okay. So, in that case, we may want to decouple the upload of data from the actual aggregation.
Okay. That's one way to do it.
So, let's say we have... So, in this case, we just have the... Let's call them collection, because they're not doing the entire monitoring task anymore. So, the responsibility of these guys is to get data from Kafka and then update the document store with the data they come in, or that comes in. So then every so often we'd have a separate service that retrieves from the document store and gets the aggregates and then uploads to the external DB. So what I'm thinking of now is it has to have a track of the current list of aggregations that exist. So this would probably have to query the table as well.
Oh, fancy arrow. Okay.
Yep. There we go. All right.
So this aggregation is also a service, right? It has multiple servers, I presume, or? Okay.
Yes.
You don't have to draw it out. It's fine. You don't have to draw it out. I just was asking.
Yeah.
Okay. And so tell me the responsibility of this aggregation service.
The responsibility would be to query the document store, get the data it needs to aggregate.
Yep.
Actually, wait. We'd first, because what I'm thinking is, like, do we want the user to be able to tune, for example, like, get the aggregates for server for, like, key 1 every so often, and then have different intervals for aggregation? Or do we want everything to be done real time?
Sorry, can you repeat that question?
So, do we want the user to customize, like, get the aggregation for, like, group 1 every so often, and get the aggregation for a separate group every so often, which is a different time interval? Or do we want everything to be processed in real time as quickly as
As
possible.
quickly as possible. Yes, everything as
Okay,
quickly as possible.
so then what the aggregation service would have to do is query the aggregations table, get all the active services that need to be aggregated, query the document store, get the data, perform whatever calculations it needs to do through like MapReduce or whatever, then upload it to the external DB that is specified by the user.
Okay.
Does this data flow make sense?
That makes sense. That seems logical. One question is, how are you planning to? And there's a couple ways to answer this. Just to preface, how are you planning to ensure that you are within the 1 minute SLA?
How am I going to ensure I'm in the 1 minute SLA? Okay.
Or maybe a
So,
more maybe a less more tactical way to ask it um, is there a way in the current design? Yes or no? That's the first question. And the second one is, if there is a way, um, what will be the cheapest way to do that?
well, there's nothing in it explicitly right now that guarantees this.
Right.
So we need to add something in. Okay. Well, since this is real time, I think we want to prioritize extreme availability.
Okay.
Like, if, for example, like we can't get the most up-to-date information, we want to prioritize just uploading something that's semi-up-to-date.
Okay. Sure.
So,
But how will you know if you're semi up to date or not? Like how will you know if your data's good?
you, to be honest, you, it's different. I would think it's not entirely easy to, let me trace this out.
Okay.
Like, document DBs probably have a way to do like replication or
Sure.
something.
Yeah.
So we may query from a replica that is not entirely up to date. Uh, I don't think we want to check if it's fully up to date because that one adds more time to the querying, and two, we want to prioritize uploading something as fast as possible. Like
Could you
I think the
what takes more time? Which query takes more time?
the query to well, if we want to check that the database is actually consistent, then we'd have to specify query like the leader
Oh, okay.
database, which is guaranteed to be up to date. But the problem is that puts a lot of work on the leader, so it defeats the entire purpose
Okay.
of replication. So I don't think we want to do that.
Okay.
So I think we just have to accept that the aggregation may not always have the most up to date thing, but
Okay.
that doesn't concretely answer the question of how do we sit within the 1 minute time limit.
That's fine. That's a harder question. So, if you don't have intuition on that one, let's move on to the next one.
Yeah,
Okay. So let me just what was that question again? Right. So currently in the system, right, we've been focusing a lot
yeah,
on like what if one aggregation key is very overloaded, right? But in reality, it's likely the
yes,
case that they'll be pretty evenly distributed for the most part. Um,
yeah,
you know, in that context where everything is relatively evenly distributed, not like exactly, but roughly. Um, and we
yeah.
scale up the number of servers and the number of keys, not servers, the number of inputs, right? System inputs. Uh, which part will we need to scale up first, or where do you see as points of failure?
Well, all the DBs are single points of failure without replication.
Is there replication? I thought you mentioned there was replication for the
Uh,
document DB.
for the document DB, I don't think we need to be super worried about
Okay.
this because like there's probably replication stuff.
Yep.
The external DB that's not handled by us,
Yeah. So we don't have to
so
worry about that.
we
Yeah.
don't
Yeah.
care. So then it comes to the aggregations table. You mentioned that it's relatively evenly distributed between aggregation keys. So what I'm wondering is if we can do horizontal sharding by aggregation key.
Okay.
So then we'd say, okay, So we'd have table aggregations. This is,
It's a bit wonky. That's fine.
yeah. So table. So we have aggregations. Let's say aggregations 1, and then aggregations
Mm-hmm.
2. And at this point, we'd still have the ID. I don't think we need a primary key for with respect to the aggregation key anymore because uh, there's already an implicit guarantee that if we're in like the aggregations 1 table, we're querying for stuff on key 1.
So you have a table per key.
So yes.
Okay.
Yes, we still have the ID, but the main point is like, for example, if key 1 does the data flow, then we do load balancer, etc., etc. When we have when we go to the aggregations
Mm-hmm.
table, it would query specifically from key 1
Okay.
or from the aggregation table 1.
Okay. I see. Okay.
Uh,
Yeah.
so
So the
yeah.
databases. All right. And maybe so. Yeah. That's a fine answer. And as a last question before we kind of wrap it up for feedback and other questions you might have, I just forgot my question. So let me just think of another one. Fuck. Okay. So let's say that So one question about this specific design is that, uh, now that we have the collection, as you called it, mechanism doing the not broadcasting but putting the data into the document DB. Can you just tell me the difference or the distinction between why the collection uh, this collection service is doing that versus just having Kafka pipe it into the DB directly?
Why?
So in
So
other words, can you distinguish the role of Kafka versus the collection service?
so the role of Kafka is to just eat up all the raw data that's coming in. Uh, the Why would we not upload it to the database directly? Okay. Like, okay, I guess the best thing would be to like see what happens if we do decide to upload it
Sure.
to the database directly. So we have like load balancing goes to Kafka, and then it decides to upload directly to the document database. The problem I'm seeing with this is if we put it directly in the document DB, we're not inherently able to. We'd have to change which metadata we're passing into Kafka, and I think it creates a degree of
Mm-hmm.
coupling
Yep.
between sending the data versus or like receiving the data versus actually like uploading it to the
Yep.
DB. So in a way, the collections service allows us to like decouple the uploading of data from or the collection of data for like separation versus the actual upload of it because Kafka's not perfect if like stuff is lost
Stuff is lost.
in Kafka
Yeah. Okay.
then it's just and it is directly uploading to the DB, then it's like okay, uh good luck. But if we're able to upload it directly to the server, then not only can we query the aggregations table to say, okay, especially since it's sharded now, we're able to query only that table and then upload it to say like a specific ID of aggregation key in the DB versus like
Okay.
yeah.
Okay. Let's call it here. Let's call it here. Good stuff. Now let's talk about what's going on here. Um, do you want me to do feedback first? Or do you want to ask questions first? What we have about 10 minutes
uh
here.
uh feedback.
Feedback. Okay.
I got kind of
Okay.
destroyed.
This one was a bit rough, but I think I'll say the good thing first. Okay. The good thing first is that there's a lot of reasons why this would work. The bad thing mostly is that you didn't identify, from what I can tell, any of the reasons why it would fail, like the like what would be the first points of failure. Um, and to be fair, you didn't really. I think there's a couple things in terms of so that's about the design, right? But I think this could have been possibly avoided if you had followed a more traditional system design process, in the sense that you get an idea for what would be the bottlenecks, right? In other words, you were trying to deduce the bottlenecks of the system implicitly through your intuition about these various services, which is cool. But also, you didn't really get any numbers to work off of. So some parts in the system I would consider highly over-engineered, aka expensive as fuck, and the other parts are a bit questionable in terms of reliability. So first things first, right? Like, get numbers for what needs to happen, right? Some people do that in the form of like just asking explicitly. I would generally encourage this, asking explicitly users, not users. Sorry, I'm thinking of the previous problem. Number of keys, average number of inputs per key, right? Maximum throughput, right? What throughput characteristics are we supporting here, right? How many outputs, and from that you can deduce key metrics in this case, which is data per 10 minutes, right? Like your bottleneck here, the entire bottleneck here is essentially the data per 10 minutes, and the amount of data you need to sift through per 10 minutes determines essentially a lot of the design, right? So the level of difficulty for this problem really comes down to how much data you need to handle in 10 minutes. So as an example, for something which I think is over engineered, is the aggregation table. Okay, now let's take some reasonable numbers. So you didn't ask for these numbers, but let's just take some reasonable numbers, right? It's pretty reasonable for a relatively large company supporting this behavior to have, in this context, about 10 million aggregations, and 10 million aggregations that aren't updated that frequently. Because keep in mind, like, this is metadata; it's not updated that frequently. You can pretty comfortably handle 10 million aggregations on one table, right? Like, the read write throughput of a table is not gonna, it's not like, that's not an issue, right? Um, if you want to, and one more thing about this, the bottom here is that, well, while talking about sharding, you don't need to shard necessarily per ID, right? That's really like, that's like if you have like a lot of throughput on like one particular item. You can shard on something like, and I think you know this, but you just didn't say it necessarily the right way. Like, you can shard on like the last 2 digits, or last 3 digits, or last k digits, right? So something like that, especially when I came and explicitly said that it's relatively evenly distributed, right? That's how you know it's safe to shard based on the ID count, and not like every single ID, right? So keep that in mind.
Yeah.
Now, let's back it up a little bit more. So I talked about the process, a little bit more about the design. Um, right, this is one thing which you need to clarify a lot more, which is a product requirement. Now, I said at the beginning, I said rules, right? They're aggregated based on rules, and that is a purposefully vague phrase, because depending on exactly what a rule is, that drastically changes the design. Okay, for example, I initially said, example of rules are averages, right? Averages, min, max, etc. Right? If the only rules that are here are numerical rules, then you could simplify the system drastically. Okay, and why is that the case? Well, for example, for something like running averages, you don't actually need to store as much data. There's a lot more stuff you can do with numbers to kind of get them to work the way you want, right? So keep that in mind. And another thing about that is, for example, let's say we have to support generic rules, so rules that are more or less arbitrary code. Well, that's like the other extreme, right? Then in that case, you have to have way more compute to be able to compute what's going on. So in that case, the bottleneck here would be undoubtedly the aggregation layer, which is what you have it labeled as, right? Now,
Yeah.
a more middle ground solution is that there's a set of rules which are pre-made. Like, we make the rules that you can pick from, right? And like that's typically a more reasonable kind, right? So like that's something which you have to clarify, because like, depending on what a rule is allowed to be, that drastically changes the difficulty. Okay, so keep that in mind. Just general clarity about the problem.
Yeah.
What else is there? Kafka, right? So when you first brought up Kafka, I got really scared because Kafka can actually do rules by itself already, right? Kafka can already do aggregations per, they call them queues and topics. So yeah, you could technically solve this entire thing by just having a tree of Kafka instances, which would work, but is not great, right? But um, the justification for Kafka here is relatively, it's I think at this level it's okay, right? But just be aware that like if you're gonna name specific technologies and not something generic like message queue, because like over here it was load balancer, here's just a table, here's a document DB, right? And you have a name drop in Kafka here, that's a bit out of place. So keep in mind that if you want to name drop specific services, then you need to like properly justify the benefits of Kafka over something like, for example, ActiveMQ. Um,
Yeah.
it's not a big deal, but just like people will be a bit, I won't say disappointed, but they'll like the amount you know about it doesn't really match up to that kind of reputation. Last thing I'll say is, what was it? Right, about the broadcasting, right? It's okay. It's okay. The main difficulty here is just that, again, like, and you recognize that this document database might not be the most appropriate for the situation, right? But again, keep in mind that this document database is not really going to be a point of failure. Two reasons for that. First of all, is that you would shard based on the aggregation ID, right? That's the first thing. So you would limit the number of aggregations a single table will be handling, right? So that's how you would control the throughput. So for example, if a document DB is getting too many, it's getting like too many it's getting too many streams now, or one stream suddenly picked up in volume. You would want to schedule further streams to a different database instead, right? And this is a general pattern that I recommend learning, which is basically the database workload balancer. Right, in this context, right, keep in mind your ID, which is the aggregation ID. This is your key for determining which database you're going to, and so you should have a service which updates your fleet of document DBs, which updates your document DBs depending on which one's under high stress, which one's under low stress, and we're spin up more databases to handle new keys coming in. So
Yeah.
so that's like a pattern that you should get familiar with. I'm sure you can understand that, but yeah, just get familiar with that, because otherwise, because you really played up that as like a point of failure, but that's really not a concern for most parts. And I said last thing. No, I actually have one more thing, which is data staleness. How do you know about data staleness? Pretty trivially, actually, if you think about it. This is time series data, so you know the timestamp of the data, right?
Yeah.
So you know when the last piece of data was broadcasted, right? Now, that's different because, for example, if your Kafka, for example, suddenly got completed, your database would no longer be updated, right? So in other words, this is another indicator that points towards that you need a database watcher or some external service, not external to the company, but like just some other service that you haven't put here that updates the database with when it was last updated. So you would have, for an ID, part of the metadata you would have here would be last updated. And so, for example, if this workstream did not get new data in the last 10 minutes, you will have no data under it, but you would still have a modern timestamp, and that's how you would know. So that was when I asked you that question, that's the kind of answer I was looking for.
Okay.
Okay, that wraps up my notes on my side. Anything from you?
So I'm curious, when you said this was challenging, is this like the upper level of new grad system
I would
design?
say, depending on the kind of company they're looking for, yeah, this is definitely within. Like with this is something which, if a company is looking to really kind of thin the pool, like this is definitely within. Yeah, this is definitely game. Now, depending on the interviewer and the company, they might ask different focuses. I did not have a focus here. I kind of just let you talk through what you had here. But yeah, like I would say this is like new grad, maybe a bit more difficult than your typical new grad sys design. And keep in mind, right, sys design is already in the more difficult rounds, like more difficult companies. So, so yeah, I mean, I would say so. Why?
Yeah, because like I'm curious what the other problem you were going to ask me was.
Like the medium one. That one was
Yeah.
just going to be about a local file system watcher. a
Oh,
local file system watcher, so it's like a local client application, and you need to detect changes to a different. Yeah. So it's kind of like Google Drive. Do you know like the Google Drive desktop application? Yeah, so
yeah.
it's like that, but you don't have to do the Google Drive implementation, just a client.
Yeah. So like a lot less in so a lot less convoluted than this.
Well, I wouldn't say this is necessarily convoluted.
Well, yeah.
I'd say that not most, a lot of the difficulty here came from you having to iterate on a design in which you didn't have good motivation to put together in the first place, right? Like you were anticipating points of failure when they weren't necessarily going to fail, and that's quite distinct from, for example, having a complex design where you had worked out the details of ahead of time, right? So that's mostly of your doing. I think you could have resolved a lot of that maybe uncertainty, I would call it, by getting the performance numbers up front, because from those numbers you can make more informed decisions and not have to go like if this, if that. So yeah. I mean, like I think that's one of the key pieces of feedback here is just to clarify the actual performance requirements for systems like this that require performance.
Okay, so get more clarity on concrete numbers and try try to keep things as generic as possible with tech and try not to over engineer stuff if you don't need
I
to.
think that's a pretty good summary. And I don't think, I mean, the second one, like keep things generic as possible, not necessarily. I'd say if you actually know something about Kafka that would help you, that only Kafka can do, then definitely bring it up. Like in this case, if you, for example, okay, so this question's pretty good because it allows for a lot of like in industry knowledge. So for example, if you knew of a time series database, so I would have subbed anything. So for example, if you're from AWS like I am, then you would know about it's called TimeStream. So if you knew that TimeStream exists and you know roughly how the API works, then the question would be, then it's like, okay, you can offload to that, but then I would increase the level of the question to compensate for the fact that you're using that service for a lot of the logic, right? So in that
Yeah.
case, yeah, you should say the name of the time series database because that makes sense because you know a little bit about it and you can justify the usage of it, right? Um, and that is definitely cookie points, but that doesn't necessarily absolve you from any difficulty because then they'll just increase the difficulty to match the level they're looking for.
Okay. Yeah, and okay, how did I do overall?
I'd say it depends on what the interviewers are looking for. I think technically it was quite strong, um, but there are two main weaknesses, right? The first weakness is that you didn't know the problem you were solving for until after you're done solving it, right? Like, what if I told you that there's not that big of a service, and that this is one thing I like to do a lot of new grads is I give them a system design with numbers that are clearly serviceable on just one computer, the entire thing, right? And if you don't recognize that, then why are you asking for the numbers? This is the other extreme, where you just pretend the numbers are really big, you over-engineer the entire thing, and then when I asked you what would fail, that was not clear because you didn't actually have the numbers, right? So that I see the biggest weakness there is just that you weren't clear on what was actually the requirement, like the performance requirement essentially. But I think technically speaking, if you had, if let's say you did ask for the numbers and they gave you something reasonable that was relatively large scale, I think this would be considered relatively strong, with the caveat that you spend a lot of time on, like, by the time I was asking you why Kafka and why are we doing, like, how do we distribute the rows to, not rows, how do you distribute the streams to line up the way that you expect? By that time, you should have already thought to myself, okay, how many streams do we actually have? How much data is there per stream? Right? If by that point you haven't already thought of that as a natural progression, that could be viewed as a negative signal because you aren't very self-aware of the limitations of what we're doing with.
Okay. So, I think I get the biggest thing, which is get concrete numbers.
Get concrete numbers, and then that's step one, right? And then step two is from concrete numbers, figure out what that means. So, as your own exercise, okay? Let's say in this context, in this problem, we have 10 million aggregations at any given point, okay? And we don't care about that metadata, so that can get updated by someone else. We don't care about that, right? And per aggregation, we have 100,000 data points per second. So that's the sum of all services that are broadcasting to that aggregation. 100,000 data points per
Okay.
second. With those numbers, on your own time, go figure out which of these services need to be scaled and which ones don't.
So 100,000 data points per second, 10 million aggregations. Correct. Okay.
Cool. Anything else before we end it?
No, I don't have anything else.
Sounds good then. Then thank you very much for your time, and I will catch you in the future.
All right, see you later.